Hey everybody, so Blake introduced me pretty good. My name's Robert. ScaleFT is a tiny startup just above the bus across the alleyway. That's true. So, right, my talk today is gRPC in unexpected places. gRPC, remote procedure call library out of Google, young but pretty active. I'm not gonna go into too much detail about that now. I hope you've studied up. Actually, show of hands, who here has heard of gRPC? Okay, you've got everybody. Awesome. Okay, that's actually great. Cool. And as far as the unexpected places go, I'm not going to tell you where. It would defeat the point. Sweet. So we're here at CoreOS because we care about securing the internet. ScaleFT contributes to this by what it says, enabling companies to adopt advanced encryption in our, usually it's CA client certificates for authentication. Adopt is the key word there. If you can't use a security product, it's useless. I think about OpenSSH CA certs. I learned about those, I don't know, like 3 years ago. And I was like, this is sweet. I'm going to use this at home. So I went home and I was like, let's get this set up. The infrastructure for this, like PKI is hard. How are you going to get this configured? You got to trust the CA cert. Then you somehow have to issue yourself certificates all the time, and you want to keep your private key somewhere, but is it going to go right next to your SSH private key? I don't know. Anyway, so, the point here is adoptability is a big deal. That's my message. Our approach to adoptability, solving the usability problems of CA certs, it's a client-server approach. As I mentioned, you got complexity on the client and the server. For the client, you really want to be able to rotate credentials in and out of the local system store. From an adoptability perspective, this means you got to run on whatever the system is. Windows, OS X. Anyone use desktop Linux here? Okay, good. Oh, never mind. Sorry, mean joke. Okay, so also you got to configure client applications to trust the CA, and you want to have a sweet UI, right? I think usability is a big deal. We can joke about it, but people got to be able to use it. So the other half of it is, on the server, you got to be able to trust the CA. This is actually not that bad. Server agents are a well-understood domain, way easier than having users use something, having a computer use software. Pretty easy, right? It's great. So, like I said, adoptability means it has to run on all these different operating systems. So over here, we got OS X, Linux, Windows. On the server, we got CoreOS, Linux, Windows. Anybody think of any other ones? Yeah, okay. So, right. On the server, then, we can look at this and we can be like, great, so CoreOS server agent, I'll write that and go. Linux server agent, I'll write that and go. Windows server agent, I'll write that and go. Cross-compiling is awesome. Then you look at the desktop client and you're like, okay, so I'm going to need to use native windowing libraries. I'm thinking OS X, Swift or Objective-C, Linux C with GTK or Qt or I don't know. I think there's a lot of options there. Windows, probably C#. Maybe I can persuade my team to use F#. Probably not. But anyway, there's a lot of diversity over here, and we're thinking, okay, great. So in order to do this on the client, there's a lot of complexity in the client. We want to have a sweet UI. We want to interface with the local crypto store. We got to connect to the API, and we've got a user that we also have to show Windows to. I guess we're going to be writing a Objective-C application, a C# application, and like a straight-up C application to do these things. We're going to have duplicated logic for API clients, for HTTP API clients. We're going to have probably some kind of system-agnostic interface over on the crypto store side. We're going to have to factor that. And then, I don't know, we're going to learn all these different windowing libraries. We're thinking, okay, so we were able to solve the server agent problem with Go. Awesome. For desktop client, it's got to interface with the system. We're systems programmers. Are we going to have to write a lot of C to do this? Yeah, we're doomed, in other words. But then we're like, well, maybe there's a way out of this. Let's imagine a better world. What if we had a Go process somewhere right in the middle of the diagram? And it factors out the logic for the API, easy, right? for the local crypto store, so you're cross-compiling. It's basically the same work we're doing on the server side. That's not too bad. And then you've still got the sweet UI on the diagram interfacing with the user. The only question is, what's this? Is it IPC? Like, I hope not. IPC, you know, complex problem to solve, especially for a security product. We drew a diagram like this, and we're like, this is probably impossible. Are we going to use shared memory and signals? I've done that before. When I was at Yahoo, we had an IPC library. You write into the shared memory segment. You like send a signal to somebody. They read out of it. I don't think it had mutex support because it had to run on so many different Linuxes. It was like, I don't know. Anyway, yeah. So I mean, terrible experience, you know. And you look at this and you're like, you know, on first glance it looked bad. On second glance, it looks even worse. Let's think about it here. You know, what are you going to do? You're going to be passing configuration information this way, but what if something else happens? This is a complex surface to explore. How are we going to solve it? You look around your engineering team. So I got some teammates, Paul and Russell. We're looking at each other. Are we going to just use syscalls? Like, should we have a FIFO? This is a worrisome idea. On the other hand, you know, it could be sweet to have like a daemon running in the background so it's not purely driven by user interactions. I don't know. It's a tough problem. Local communication. So we're thinking about what security flaws are exposed here. What if somebody could snoop over it, you know? We've seen some failures in that domain in the past. I hate to call out OnePassword. I love OnePassword. Does anybody know what that link in the upper right probably goes to? I heard a laugh. Yeah, so this is a little sad, right? So OnePassword was trying to do an architecture like this on their client app. They have a browser plugin. It needs to interface with their long-running, you know, crypto store. Similar kind of problem space to us. And they used unsecured local HTTP. You're like, well, there's the password going over the network socket. Like, that's rough. We don't want to do that. You look at their response. It's worth reading. You know, they're going to say, what are you going to do to defend yourself against a user on the local machine that has root? You can't protect against that. Plus, you know, you want to use mutual authentication, but that's actually, it's uniquely difficult to do that with a local host API. So it's something to think about. We're thinking about a local host API. What do you want to do? Like, what if we were going to do this? You may be guessing that we did do it, but I'm not going to tell you how. We're thinking like, what do we want? I mentioned mutual authentication. We got to have that encrypted. I guess we probably got to have that. High performance is important too. If you're going to interface with a user, you want to be able to like respond to click events. You want to be able to have information update rapidly. User experience is the whole point of this application, so we can't compromise there. And you also want it to be simple. You cannot have a complex failure surface. It'd be ridiculous to just, you know, like I said before, I mentioned mutexes. Like, we could try and solve this problem the traditional way, and the traditional problems are well understood. And so we know that in the great tradition of IPC, we would fail. We definitely don't want to do that. So what are we going to do about it? Well, we're talking about Golang. We already been writing gRPC stuff in Golang. You might have guessed gRPC was going to come in handy here. So super fast. I've actually been really impressed with how fast it is, and I think it's ridiculous to talk about performance from the standpoint of when you choose a library. I mean, the interface is what's important, the API it exposes. You shouldn't care about the performance of a library. But this is so fast. I don't know. Anyway, yeah, so the API, really super simple, really easy to understand, but you know, when I first looked at it, I was like, great, so it's got like 3 features, you know, I can probably solve a problem with this, but the great thing about it is it's not complicated. It's really easy to come up with the right solution. If you have a simple API, either solving the problem is impossible or it's perfect. And in the case of gRPC, I'm pretty happy. You know, functions only have 1 parameter. They have a streaming support, which makes sense for a UI. I think I mentioned that there. Yeah, so I mean, you can imagine an event bus where the daemon is pulling the API and pushing notifications to the user. You know, it's pretty sweet. Or like if a credential is going to expire, you might want to update it, update the status of that credential in the UI, and you can just push that event over a stream. It's awesome. So anyway, I don't know, it made me so happy. We were actually able to do this, and we turned what was going to be multiple monolithic C, C#, Objective-C applications into a couple thin UI layers. They're kind of views into the Golang daemon, and the interface is all done in gRPC, and because gRPC has libraries in all those languages, we're able to do that. It's pretty great. Made me really happy. I mean, I love C. I don't want to be a hater. I also don't want to have any buffer overflow exploits, or I don't know. Go is so much nicer. Oh yeah, I forgot to mention, so, you know, ScaleFT, we've got a team, engineering team. We're all going to learn everything anyway. People are going to push commits to the UI layer, but it's nice to reduce the API surface that you have to be familiar with. You don't want to have your whole team have to understand the subtleties of using asynchronous I/O in C# and Objective-C, because you really want to delegate that suffering to one individual. You don't want to spread it out over everybody. It lets many of us be happy, and then me and Paul have mostly been doing the client-side work so far. We're also pretty happy. We're thrilled. So anyway, that's my first story. The unexpected space that gRPC popped up in was a desktop application. I didn't see that coming. We think about RPC libraries as a way to implement terrible message queues or to introduce unreliability into your client-server application. But instead, on a local machine, you know, totally secured via client certificates, it's awesome. So that made me really happy. So this is my second unexpected place, and I'm not going to tell you what was hiding in that unexpected place, but it might be an RPC library. ScaleFT, we try to keep our architecture simple. We've been trying to not get into too much trouble with our design decisions. We didn't want to bind a port in our application, but it turns out to support certain features for certain use cases, it's good to bind a port. So we were like, well, hey, we're going to bind a port. Let's apply to IANA and get a port number assigned to us like you're supposed to do. We've asked several friends of ours if they do that, and nobody apparently does that, which is probably why we were able to get such a sweet port number. We were expecting something in the 63,000 range that we'd never be able to remember. We got 4421. I'm pretty happy about that. I was thinking, you know, did we write like a really compelling application? Why did they give us this number? But the conclusion I've come to is people just don't apply for ports. So go get a port. There are really good ones out there. Anyway, so like I was saying, we expose this, we expose on the server agent, we expose selectively, sometimes we expose a port for remote management. From a consistency standpoint, if you're come on, like this is a distributed systems group here, right? If you're orchestrating a bunch of machines, you know that if you try to use some central store of knowledge for information because you want to aggregate it in one place or query it really easily, it's going to be inconsistent. For some pieces of information, the server is the source of truth. So you're going to want to write to it if you want to change that, or you're going to want to read from it if you want up-to-date information. It's not partition tolerant, but it's consistent. Consistency that's my favorite of the three, let's say, distributed system virtues. Consistency is it. So we're looking at this. We're like, great. So we've got a server crypto store. That's more of an example of the type of administrator-only local resource that we might want to provide access to. But it's a good example, though. You care about that. So we got the server crypto store. We're going to have to make some syscalls into that. The process making those syscalls has to be authorized to do so, or we're going to get caught up on, you know, whatever the permissions are on the respective operating systems that we do this on that protect you against people exploiting your crypto store. Great. So then, according to this diagram I've got right here, this box in the middle has permissions to modify the crypto store, but it's also bound a port which is routable on the local network at a minimum. And you're like, I don't really want my process that binds a port to have root. This is a pretty well-known principle, right? I mean, everybody's with me on this page? Okay, I mean, it seems like we have consensus. You don't want to do that. So just like the other situation, I drew a diagram. This is exactly how we were working on it as a team. We're like, well, let's draw a diagram of what we don't want to do. Here's a solution to the problem that we cannot do because this is ridiculous. Any 0 day, which by the way, if you've been paying attention, you've updated your version of Go in production a couple times. Any 0 day against this, bam. Anyone executing code in the context of that process has access to the crypto store as well as whatever else. And you're like, don't feel good about that. I wouldn't feel good about that. So we're like, basically, we can't do it. This is why we weren't going to bind a port in the first place, but IANA gave us this sweet port number, so let's do it. Here's the principle of leaf privilege. That was the title of this slide. I love that as a concept. I think it works in social situations as well as in software design. So yeah. The goal is let's come up with a different diagram that lets us expose a service via port 4421, which is sweet, without root. So that's actually, this is a traditional problem. Probably at least a third of the people here have had to solve this problem on Linux before. There are a couple different idiomatic ways of doing it. I think, we wouldn't consider it a big deal. But in Go, it's actually a little more complicated, especially when you're trying to do a cross-platform solution to the problem. Whenever you want to develop an interface for something that works on multiple different operating systems, you're like, you need a very simple interface that you can support whatever the underlying complex semantics are from. So that's why this seemingly not too hard problem got a little harder. Here is a new diagram, right? So this is kind of what we're trying to target, right? We're like, okay, so we're going to have one process on the left. This process binds the sweet port, and it only has permission to bind the port. And somehow there's some interface, as yet to be determined, and I'm sure no one knows, that communicates to the daemon. And the daemon has the administrative permissions that allow you to connect to the local crypto store. Okay, cool. So how are we going to do that? Let's think about it here, right? So I mentioned mutual authentication before. We really want this to be a mutually authenticated. We don't want the daemon, for example, to just accept over whatever. This is kind of similar to the desktop client problem. You don't want to just accept any incoming connection and then handle that, right? You want to be able to verify it. It's not enough that it be encrypted. You have to know who's issuing it. Similarly, it really depends on what the API surface is here, and I'm not going into detail on this. Obviously, that arrow on the far left exposes an API. You don't necessarily know what's in the API. Could be important. So we probably don't want to enable anyone to impersonate the daemon and have the lower privileged service connect to it either. Mutual authentication. Everything should be mutually authenticated. This is, I don't know, it's a moral lesson. So great. How are we going to do that in Go? What's the solution here? So gRPC. I'm going to get on to how this works, because this slide is very, very short. This one is a little more detailed. So this is kind of a long process. I'm not going to read it to you, but the essential idea is you start the daemon. It has high privileges. It's ready to do its work. It creates a child process. This is a cross-platform concept, right? This child process has reduced permissions. Then we represent that in a way that varies with the platform that it's on. It can bind the port. So now the only problem is, how do they connect to each other in a way that's mutually authenticated? So because we have a parent-child relationship, we scoped the child's lifespan on the parent, and we did that using the standard in primitive. It's really simple. You open the pipe, the standard in pipe, and then whenever that pipe closes, the child will exit. So there's no chance that it's going to be hijacked. We use standard in. You're probably thinking, except you already know I use gRPC for this. However, if you were a traditional Linux programmer who heard someone say, hey, I have a child process with standard in, you're going to say, oh, you must be serializing your control over standard in and standard out. Like, you're basically doing RPC over pipes. Okay, it's Unixy, I get this, right? But no, we're using gRPC. It's on a second socket. This has a number of advantages. It's not subject to the same flaws as the previous approach. So what happens is we use standard in for the configuration information only. That configuration information contains what's needed for mutual TLS authentication. Sorry, I'm talking really fast. But and it also contains the information the child needs to connect to the parent, which in this case is a random high port that it binds before it starts up. So I don't know. It's a pretty good experience. I mean, I'm telling stories where we start out with a sad diagram and this is the challenge we faced. But then at the end of it, I feel good. And that's for me, that's an unusual feeling when you get to the end of a software solution. You're like, did that really just work? Yeah, it worked. We've got mutual TLS authentication. It's encrypted. We're using gRPC. The child exits. There's no way to hijack that connection. So gRPC enabled this. It's a really good feeling. This is kind of where I'm trying to get to. Technically, this is a security talk. You should feel scared. But the reality is, this is a fest. You should feel good. Let's celebrate good tools. That's kind of my point here. gRPC, which I haven't gone into enough detail on, it's a simple project, but it would be hard to do it justice. so I just thought I'd tell some stories about using it. But gRPC really enabled us to have great factoring for our software components and for our team so that we don't have to delegate information the same way. The API is subtle. It's worthy of study. They actually have like kind of a design principles page on the website. I would recommend checking it out. You know, streams, great. Cross-platform, great. You know, it's actually interesting. So we got libraries in Objective-C, C#, and Go. Those languages each implement sort of different parts of the total feature set. It's an in-progress thing. They start with a priority list of what does an Objective-C programmer need an RPC library for, right? And that's actually, I mean, I'm asking that question seriously, but that's a question you could ask sarcastically too, and probably somebody did once. The reality is you do need it, right? So it's being developed, and they develop it in order of priority for what Objective-C programmers want, which is subtly different from what Golang programmers want. It's kind of fun. I mean, it's worth digging into and checking out. So then, yeah, I said gotta love certificate authentication. On that note, actually, my team pushed some patches to a couple different clients. It turns out, like, client certificate authentication is not the top of the list when it comes to like a C# developers list of priorities for an RPC library. You know, people care about different things, but Go has great support for it. I think the crossover between gRPC and Go in terms of design sensibility is pretty high. And so people care about this stuff. I don't know. It's awesome. Isolation, I mentioned that there. You know, I'm thinking about, you know, Conway's law that the design of software components maps isomorphically to the institutions that create them, sort of the barriers between teams or departments. I don't know. Anyway, so you have good isolation in your software. You don't necessarily want isolation on your team. It's actually, you have the inverse result where people are more enabled to collaborate. In the example of the desktop application, you know, we had a sweet Golang library that implements all the business logic. People can really iterate a lot faster there. You don't really need to change windowing, you know, UI stuff as frequently as you do. You need to update your API. Yep, I think that's it. How did I do on time? I'm a little early here. Okay, 6 minutes. Anybody want to ask any questions? Rob's got a mic. I don't know any answers, but I'll say something. No? Okay, so I covered mutual TLS authentication. I'm going to ask you guys some questions. Who here does not know what that is? Okay, almost everyone knows what that is. Chance? You don't know what that is? Okay. All right, everybody knows what mutual TLS, well, okay. So everybody knows what that is. Who here knows what a client certificate is, or what a certificate authority is? Actually, let's go the other way. Who doesn't know? Expose your ignorance, Chance. Okay, that was a good response, actually. These are things that we should really care about. What's up, dude? Oh, we got a question. Great, that will help a lot.
So how you consider the Swift?
Swift, you mean instead of Objective-C?
Instead of gRPC, yeah.
Oh,
Thrift.
Thrift, yes.
Thrift, yeah.
So at the beginning, great question. So the question is, have we considered Thrift? Thrift is an Apache project. It's also an RPC library. It's also something that you use to generate clients and servers across pretty much every language. Thrift has been around a little while. A lot of really successful projects use it. I spent personally about 3.5 years maintaining a distributed system that used Thrift. I'll never forget it. I don't want to be a hater. For me, this is all about love. Thrift has some advantages and disadvantages. Like I said, the language-oriented verticals in gRPC, you also see those in Thrift. There are obviously some languages that the Thrift developers really care about, and then there are some other ones that they include for completion. I think the thing is, yeah, okay. I don't want to be a hater. Okay. Yeah, I'm not going to be a hater. Thrift is great. It's better than Corba. All right, I'm sorry, I know that. We can talk afterwards. Any other questions? All right, let's call it. Thanks, everybody.